Finally, we can get to assembling the frame itself now that we have a bunch of the sub-assemblies taken care of. First thing we'll do is unwrap what I call our angled arm mounts. These are two solid steel pieces of sheet metal that hold the angled XY gantry onto the printer. We also have 4 aluminum V-slot extrusions that make a bottom portion of the frame. 2 of them are 2020 and 2 of them are 2040. The 2020 bottom frame pieces go on the left and right side of the machine, and the 2040 aluminum extrusions go in the middle of the machine as we lay out on the table here. These pieces are held together with M5 bolts, much like our other sub-assemblies. I found it a little bit easier to attach these beams by holding them upright. It was a little difficult to do with only one set of hands, but I made it work. First, we will attach the front 2040 V-slot extrusion. And now the back 2040 V-slot extrusion. Here we have to use one of the sheet metal plates, and the 30mm M5 bolt actually goes through the sheet metal and through the 2020 extrusion and threads directly into the 2040 bottom frame piece. And we can use one M5 by 20mm long bolt to secure the back of the angled arm bracket. When I started trying to get these bolts into the 2020 extrusion, it seemed like I'd actually tightened some of the other bolts first a little too much, and that caused some slight alignment issues. But by loosening up some of the bolts that I had put in previously, everything went together really nicely. So now we have 3 of our aluminum V-slots attached to one another, and now is a great time to add the slide-in T-slot nuts for the heated bed and the LCD screen. So we will take 6 slide-in T-slot nuts, and we will put 2 of them on the inside channel of both of the 2040 V-slot bottom extrusions. And we will take 2 slide-in T-slot nuts and put them in the back channel of the front 2040 V-slot channel in the bottom of the frame. And we can use our M5 by 20mm bolts to attach the second 2020 V-slot beam. And again, we can use our steel plate on the back of the machine with a bolt that goes right through the 2020 V-slot and into the back 2040 V-slot beam. And we want to make sure all of these bolts are nice and tight. In our next step, we want to mount the X and Y motors to the 2020 angled arms of the printer. And here I lined up one of the angled arms with the sheet metal bracket on the lower portion of the frame, just to kind of eyeball where I wanted the mount to sit. In hindsight, the exact positioning doesn't really matter. And we'll use 2 slide-in T-slot nuts and 2 M5 by 8mm long bolts to attach the sheet metal motor mount. This is the older version of the sheet metal motor mount that I can see here. We did a post updating what the brackets will look like in our second batch of printers and beyond. And now we can do the same thing to the other angled arm of the printer and the second motor mount. Now we can take one of our NEMA 17 motors and use 2 M3 by 5mm long screws to attach it to the beam. And we'll do that with the other beam also. Side note, if anyone noticed the not so great surface finish in the black anodizing on this beam, you're right. Good eye. And some of the very first shipment of V-slot profiles we got didn't have great surface finish, so I chose to keep the defective beams for myself and my printers and ship out the ones that looked nice to customers. Now, just to prep for the future, we can add our GT2 pulleys to our motors. Here I was just attaching them simply so that I wouldn't lose them while building. But if I were going to do this again, I would actually flip them over 180 degrees from where I'm showing them here, and have the thick part of the pulley towards the very top of the motor shaft. Now we can attach the arms with our X and Y motors to the same sheet metal mounts using M5 by 20mm long bolts. They go through the sheet metal and thread directly into the 2020 V-slot extrusion that we're using. Next, we can prep the top bar of the printer. For this, we're going to need our top bar 2020 V-slot, and we're also going to need our 2 corner idler mounts that we prepared earlier. We can use the M5 by 20mm long bolts included in that subassembly kit to attach them to the extrusion. Before we attach that top bar to the printer, we need to slide our x-axis onto the 2 angled arms of the frame. To put together the x-axis, we will slide our completed extruder assembly onto the x-axis 2020 extrusion, and then we will take our 2 XY roller subassembly pieces and we will loosen up the T-slot nuts on the underside and slide those onto the extrusion as well. Here we can tighten them just a little bit, but we'll need to adjust them once we actually slide them onto the angled arms to make sure that everything is nice and square, so no need to fully tighten them at this time. Now we can pull the rest of our frame onto the work table and slide our x-axis onto those angled arms. First, it's really important to remember to slide 1 T-slot nut into the right-hand angled arm of the machine. This is where we will attach our Y end stop at a later step. Making sure that those T-slot nuts are loosened on the x-axis rollers, we can slide it into position on the frame. Here I'm tightening things up, but again, we don't have to have everything perfectly tight at this time. We want to make sure everything is square first, which I'll show you in just a minute. Now we can attach the top bar of the printer and use 4 more M5 by 20mm long bolts to attach it to the threaded holes in the angled arms of the printer. and we will tighten up those bolts as much as we can on the top bar. Here I'm going to try to get the x-axis as square as possible. And for some reason I thought the easiest way to do this would be to square them up according to the brackets on the top bar. So I loosened up the 8mm long bolts on the x-axis just a little bit and allowed the V-slot wheels to come in contact with the top brackets of the frame. And assuming that all of those are nice and square, then I tightened the bolts on the x-axis. In hindsight, it would have been equally as easy to allow the V-slot wheels to come in contact with the two angled arm mounts on the bottom of the machine and square up the x-axis that way. Now we can move on to attaching the conveyor rollers to the frame itself. The first thing that I will do is prep the bearing mounts for each roller. We can prep those by putting the M5 by 8mm long bolts into the holes on each mount and loosely attaching a T-slot nut to them. That way, they can slide easily into the V-slot extrusion on the bottom of the frame, and we can tighten them up later. Next, we can attach our conveyor belt axis motor to the frame itself. Here we'll use 4 M3 by 5mm long screws to attach the motor to the steel bracket. Next, we can attach our GT2 pulley to the motor. Next, use the M5 by 8mm long bolts and sliding T-slot nuts to attach the motor to the bottom of the front of the printer frame. Next, we can attach the front roller of the conveyor belt to the printer using 4 M5 by 20mm long bolts and some of those sheet metal bearing mounts. So again, there are threaded holes on the aluminum extrusion itself, and we can move the bolts through the sheet metal and thread them into the frame. These rollers are mounted differently than the conveyor roller at the back of the printer for a very specific reason. By having the holes threaded in the front of the printer, we're able to make sure that the front roller is perfectly square with the frame, and then the back roller is attached differently so that we can move it into place to tension the conveyor belt later on. And once the roller is in place, we can tighten up all 4 screws to securely attach the front conveyor roller. It's important to note, if you didn't notice already, before tightening down all of these bolts, make sure the closed loop GT2 belt is positioned around the roller. Otherwise, you'll have to take the whole thing apart to put the belt back on to be able to attach it to the motor itself later on. And yes, I've made that mistake many times. Now we can securely fasten our conveyor belt axis motor to the frame. By sliding it towards the back of the machine, we can create tension on the closed loop GT2 belt that will drive the front conveyor roller. And we can tighten the 2 bolts on the bottom of the sheet metal mount to make a tight connection between the 2. Now we can start to attach our heated bed to the printer. So we have 4 sheet metal mounts for the heated bed, and we will use M5 by 8mm long bolts to attach them to each of the 4 sliding T-slot nuts that we put into the 2040 bottom portions of the printer frame. At this stage, they don't need to be super tightly attached to the frame in case we want to adjust where the bed sits along the width of the printer later on once we attach the control box and the power supply. Now we can gather our heated bed and heated bed bolts and springs to attach it to the printer. It was a little bit late at night, so you can watch me struggle a little bit to put all of these pieces together at this stage. But essentially, this works just like any other heated bed spring system on a common 3D printer, where the M3 bolt will go through the spring, through the lower sheet metal mount attached to the frame, and then a thumb screw will keep everything attached together at the bottom of that M3 bolt. Once all 4 screws are connecting the heated bed to the heated bed mounts, you can tighten down all of them fully. This is important for when we attach the conveyor belt at a later step. Just to make my life a little easier at this stage, I used a spare bit of GT2 belt to loosely tie the X-axis so that it wouldn't be all the way at the bottom of the angled arms, and I could work with the heated bed a little easier. You definitely don't have to, but at this stage I thought it would be a good idea to unwind the wires so that they could fall all over the place and get in the way while I continue to build the printer. Our next step is to attach the GT2 belts to the X and Y axes that will actually move the print head around. Our first step is to make sure our pulleys are facing the right direction on our X and Y motors. Again, I'd recommend having the thicker portion with the set screws towards the very top of the motor shaft, the furthest point away from the body of the motor. And at this stage, we want to make sure that the pulleys are loosely attached to each motor. If they aren't loosely attached, and instead they are really tight on the motor shafts, they won't be able to rotate freely when we're attaching the belts. And this can cause issues where the tension on the belt might try to pull the X-axis bar out of square with the machine. So make sure they are loosely attached and able to still spin freely when we are attaching the X and Y belts. You can start wherever you'd like when lacing the belts through the machine. Each belt will go through 2 idler bearings on the top of the machine. One bearing it goes through should be positioned higher than the other, and the belts crisscross in the middle of the machine. I know it may seem a little concerning, but I've been running the same belts for years before seeing any noticeable wear. That's how minimal the contact is at the top of the machine. If you're looking at the machine from where I'm standing, one belt will run along the perimeter of the machine from the top right-hand post on the extruder mount to the bottom left-hand post. The other belt will do the opposite, running from the top left-hand post on the extruder mount to the bottom right-hand corner. Zip ties are able to hold them in place once they are tightened. Before zip tying them, however, I like to keep them loosely in place by using either a binder clip or a clothespin while I'm routing the belts. Truth be told, I thought this top-down angle would be really good for routing the belts, but I'm not 100% happy with how it turned out. If you're looking for some different angles, you can always resort to the first assembly guide video that I published a while back. Now that the belts are in position, I'm checking just one more time to make sure that the pulleys on the X and Y motors are in fact loose on the shafts and are able to spin freely. Now we can tighten up the belts and zip tie them in place to secure them. By pulling on the GT2 belt, we can make it tight and tighten up the zip tie. And for the other side, we will do the exact same thing. Then we can trim the excess off the zip ties and the GT2 belts and retighten the pulleys on the X and Y motors. Now that the frame is complete, we can move on to attaching the LCD screen and the control board.